All right, so with this video, what we're going to work on is a little bit of right triangle trig. So we're going to do two things. We're going to work on trying to find an angle measure in degrees. So that means our calculator mode needs to be in degree mode, not radian mode. And then we also are going to try and find a missing side with this one. All right, so we've got some information. How can we find that missing side length? All right, so the first one that we're going to work on is how do we find this angle theta in degrees given this information. So we're going to go back to what we did before where we were working with like regular right triangle trig. This is my hypotenuse. If I'm looking at angle A or theta, that has to be my hypotenuse. This is my opposite side, and this is my adjacent side. So given that information, I can start to use sine, cosine, and tangent. So we're going back to this, our SOHCAHTOA. So the two pieces of information, the two side lengths that I have are my opposite and my adjacent. So I'm going to use the tangent. The tangent of some angle that we don't know yet is equal to this ratio of my opposite over my adjacent, 8/9. Now, what we're going to do is we got to solve for theta. So I got to take the inverse tangent of both sides. So I'm going to take the inverse tangent. And when I take the inverse tangent, I'm actually going to take the inverse tangent of this ratio, the ratio of my sides. And when I do that, I'm going to get back to my angle measure. And I end up getting about 41.634 degrees. All right, so if we want to find an angle, you're going to eventually have to take an inverse trig value, all right, inverse trig function. So whether that's sine, cosine, or tangent, you're eventually going to have to do that. And you need to know a ratio of sides. You have to have two sides. If you don't have two sides, you cannot find that angle measurement, right? So now what we're going to do is for the second problem, we're going to do very similar. We're going to try and find a side length, but this time we're going to still use our trig. But now I have one missing side, but now I do have another angle measure. All right, so same idea. Here's my hypotenuse, here's my opposite side, and here's my adjacent side. All right, so we're still going to our SOHCAHTOA. And what I'm going to do now is I'm going to look and see what I have. I do not have my hypotenuse, so what I'm going to do is use my opposite and adjacent. So I'm going to use my tangent. So the tangent now of my angle, which is given now, is equal to the ratio of my opposite over my adjacent. So what I'm going to have to do is I'm going to have to go ahead and do some solving. All right? We're going to go ahead and write this over 1. I'm going to do a little bit of cross multiplying here. All right? X times the tangent of 57 is equal to 10. I'm going to go ahead and divide out the tangent of 57 to both sides because that is just a number. If you type tangent of 57 into your calculator, you get a decimal. Now all I have to do is type that in my calculator and I'll get my missing side, which is about 6.494. All right, so we're just using trig, sines, cosines, and tangents to be able to help us find either a missing side length, like this problem, or my first problem, trying to find a missing angle. Now remember, always, if you're going to find a missing angle, you're eventually going to have to take an inverse trig function, whether it's sine, cosine, or tangent. You got to figure out, from the sides that they give us, which trig function we're going to be able to use to be able to help us find that. And that's how you find missing angles and missing sides in right triangles using sines, cosines, and tangents.